Hi everyone, today I want to share with you a very simple R code I started using recently to do qPCR analysis. Since my first paper as a PhD student to the latest paper from my lab, there is one technique that appears in all of them, and that is qPCR analysis. For years I have been using Excel to crunch the data, but the method is error-prone, difficult to debug, and difficult to scale. In this video I will show you the script that I use to, in one click, generate publication quality figures, including the statistical analysis. So I hope you use the short script that I'm about to show you, and it saves you tons of time through the years. The plan for today is to walk you through the three parts of the script using a standard experimental design so that you would see how the process works and you will have the tools to tweak the script if you need. The first part of the process is loading the metadata. So for this, the first thing that we want to do is shift the data from Excel to R as soon as possible. For this, I use an Excel template. In the first sheet, I put the raw data as it comes out from the qPCR machine. In the second sheet, I extract all the raw data that I need for the analysis, which will depend on the format your qPCR machine exports the data. So all these values are linked to the raw data in the first sheet. In the third sheet, I keep the metadata just to have everything in the same file and avoid confusion. For this hypothetical experiment, we want to understand how mutations to a given protein affect the regulation of our GeneX. So we have a first condition where we do not have the protein that we highlight here as neg. As a second condition, we have the wild type protein, that are these three following samples. And the two last conditions correspond to mutations of the protein. So we have mutant 1 and mutant 2. You typically do these experiments in batches at least of 3. For example, you analyze all the conditions on 3 different days, and this is what is represented in this last column here. So these are all the conditions ABC, 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 and BC that we replicated 3 times. Okay, we are almost done with the metadata, and this is a step that you cannot avoid. You need to specify the script what you want to analyze. We actually do the last step of the metadata setup inside the script. And here we need to specify which is our housekeeping gene and which is the gene we are interested in measuring, that we highlight here. Then we need to specify which treatment is our baseline. In our case, we will be using neg, where we do not have the protein of interest expressed. And that's it. Now we just need to run the script. So I will run the script and we end up with this beautiful plot and the statistical comparison between wild type and the 2 different types of mutants. As you can see, the first step of the pipeline is to import the data from Excel. And this is what we are doing here. We then do some basic analysis to calculate the mean of the technical replicates used in this case, and this is the table that we get for each condition and each biological experiment. Okay, now let's move to the second part of the script where we do the delta-delta-CT analysis. This is the standard way of analyzing qPCR data. So qPCR is a comparative analysis where the expression of a transcript is compared to the expression of the same transcript in another cellular context, and that's the first delta. The second delta is to compare housekeeping genes that should not change between the conditions to provide a normalization of the comparison between the genes of interest. The CT in the delta-delta-CT comes from critical value or times, where the signal from the PCR becomes detectable and therefore reflects the abundance of the transcript. So in the first of this time, we get the critical values for the housekeeping and the target reference gene. And in the 2 following chunks, we do the same for the different conditions. So this is, for example, the table of the CT values for the target gene in the different experimental conditions. Finally, we do this exponential calculation to actually determine the relative change in expression of our target gene in the experimental conditions compared to the control condition, which leave us with the table of fold change between the reference conditions and the rest of the conditions. So now let's move to the third part, that is doing the statistic and plotting the graph, We do this using the powerful ggpubr library. So here we are loading the ggpubr library, and then these are statistics that allow us to get the different comparisons. So let me comment this for a second. And if we launch now the plot, we have that all the standard deviation and box plots and the position of the different values appear here. But we need this line here to do the comparisons. So we are using the t-test to do the comparisons, and we end up with this plot where we have all the statistics in addition to the standard deviation and the box plot. And these are the comparisons between the different groups. This is all done automatically by the program. Okay, that's it for today. If you find this valuable, please subscribe to the channel so that more people like you can find the content, and this can be you in the future. So I will see you then.